All right, guys, we have 7.2b today. Obviously, I'm out, so this is the first of 3 videos, and then you guys can start the homework once these videos are done. I'm going to skip the warm-up. You can skip that. It's just a little warm-up we would do if we're all together, but not a big deal. So basically, today what we're doing is it's really just factoring, and it's like division. Obviously, with division, like if you divided 10 divided by 2, you get 5. But if you just factored out 2 from 10, you'd get 2 and 5 that way as well. So factoring is very similar to division. So when we talk about these polynomials, I know you divided them last time, but what if I didn't give you something to divide it by? Could you still get all the factors of the polynomial? So sometimes you get polynomials that have factors that are clean that can come out. And so I don't have to give you anything to divide by. You can still break it apart just through factoring. There's a lot of types we can do with this. The first one is GCF factoring, so greatest common factors. You can always look to pull those out. That is always what you look to do first. So if you look at this first example, and you say, all right, well, what do all 3 terms have in common, right? Because this is a cubic polynomial. You say, all right, well, they all have 2x in common. So I'm going to pull out 2x from each of these, and that would leave me with x squared minus 8x and then plus 7. And so you've done the GCF part. Now notice you have a quadratic that is factorable. So you could factor that even further. And so you get 2x, and then we are left with, we're going to have x minus 7 and x minus 1. And so that's like completely factored. If it said solve for the zeros, you would say x equals 1, because you set that equal to 0. You'd say x equals 7, and you'd say x equals 0. You'd actually set this part equal to 0 as well. 2 is not a 0. I mean, if you set 2x equal to 0, you divide off the 2, I guess, but you'll get 0. And same thing with this one. Again, if you did a GCF, I would say, all right, well, each of these terms have 5, and then also an x squared. They also have x squared in common. And that would leave me with 4x squared. And then if I divided negative 45 by 5x, I'm going to get minus 9. And so again, you're going to get some zeros here, but you're also going to be able to factor this one a little bit further. So we're going to keep the 5x squared on the outside. This one here is actually a difference of squares. If you guys remember from quadratics, this breaks into what we call conjugates. So we have 2x plus 3 and 2x minus 3. And so that's it. It's completely factored, and all you did was just look up the GCFs. We didn't have to divide, didn't give us any of these factors to start with, didn't give us any zeros to start with. We still broke it down as far as we can. And if it said solve for zeros, you get 3 halves, negative 3 halves, and you actually get 0 twice. So the number 0 would be a double root because it's x squared, right? Because if it's a degree of 4, you need 4 zeros from it. So 1, 2, and then 3, 4. And that's it. 3 unique numbers, 4 zeros in total. So your critical thinking, if all terms have an x in common, what's a 0? Well, the number 0 would be a 0. Every term has x in common, right? You could factor out the x, which means if x is equal to 0, the whole thing is 0. Or if you just look at it, if you plugged in 0, you'd get 0, right? If you plugged in 0 for x here, you'd get 0 as a result. So that's that one. And the second one in the first video is a special factoring pattern. They're called differences or sums of cubes. And so anytime you get a polynomial, which is only 2 terms, and one of them is a perfect cube, or some variation of perfect cube, you can break it into a sum or a difference of cubes. We're going to start with a difference of cubes first, but it works for a sum of cubes. Now, what does this SOAP thing mean? I'm going to show you in a second. So if you have this and you were told to factor this, there's a way to do it. Now, if it said equals 0, you might think, oh, I'll add 27. I'll take the third root, and I'll get x equals 3. But, again, it's a degree of 3. You should actually get 3 zeros, not 1. And so that's kind of what happens. These factor into a very special factoring pattern, which is going to be good for you guys to just kind of know the pattern. But it does follow this thing called SOAP. So what it means, I'm going to drag this SOAP part down a little bit so we can reference that as I go through this. But what SOAP basically stands for is going to tell you how it breaks down. So when you see a sum or a difference of cubes, you might be better off just writing it as x to the third and then minus 3 to the third, right? If this was 27, or if this was like 26 instead of 27, it wouldn't work. But if you think of it, x to the third minus 3 to the third, we are going to work with x and we are going to work with 3. And so a difference of cubes, or a sum of cubes, is always going to break into a linear binomial, which is going to be something like that. And it's going to break into a quadratic trinomial that will be prime. It's not going to be factorable. So the linear, right, the linear part, the binomial part, one with two terms, is going to just be the x minus 3. It's going to be the same thing as these, like the cube roots of these. So it's going to be x minus 3, and that's what's going to go on the inside there. And again, I'm taking the x from this, I'm taking the 3 from this. Now, how did I know that it's minus? That's what the S in SOAP stands for. S stands for same. So we would use the same sign, not subtraction. In this case, it is subtraction, but it just stands for same. So S stands for same. So if this one was subtraction, this one's going to be subtraction. And then inside the quadratic part, right, you can probably guess, it's going to have to be like this times this equals x to the third. So this is going to end up being x squared. And then kind of like it's going to have to multiply to negative 27, like factoring is just a reverse of FOILing. So it would be this times this. And so that's going to end up being 9, right? And then the middle term is going to be when you multiply these two numbers together. So x times 3, which would be 3x. And now it's like, well, which signs do we use? Well, that's what the rest of this, the OAP in SOAP stands for. So the O is the next sign we're looking at, which is going to go right here, right? The first one was here. This O is going to go right here, which means opposite. So if this one was subtraction, this one is going to be addition. And so that's going to end up being the opposite sign. And then AP is one thing it stands for, always plus or always positive. It's always going to be a plus sign in the end, guys. And so that is how this factors. And if you want to pause the video and check it, go ahead and distribute the x and distribute the negative 3. You'll find that everything cancels except for x cubed minus 27. That's exactly how it factors it. So you guys can, again, if you didn't pause the video for the check, pause the video to do this one, see how you guys do, and then I'll give you the answer. All right, and so for this one, I would think of this as 2x all to the third minus 1 to the third. So it's going to be 2x minus 1. And then in the inside, the 2x, the first one squared, actually end up being 4x squared. And then it's going to be a plus sign because it's the opposite sign. When you multiply the 2x times 1, you're just going to get 2x. And then the last one is an always positive, and that's also going to be 1. And whether it's a difference of cubes, of sum of cubes, it doesn't make any difference. So if you guys want to pause the video one last time, go ahead and do this one. It works for sums of cubes as well. And so if you've done this one already, right, the cube root of 64a to the third would just be 4a. That's what we're looking at here. And the cube root of and the cube root of 4a. Cube root of 125 is 5. So we're going to use a plus here to begin with because it's the same sign as what starts the question. So plus, plus. And then we have the quadratic part, which is going to start with the first one squared. So it's going to be 16a squared. And then these two multiplied by each other would be a 20a. So minus 20a because it's the opposite sign. And then the last one's always positive. And so the 5 squared would be 25. And again, to check it, you can certainly FOIL it out. But that concludes our first video.